This is section 2-5, and this is going to be the chain rule. And the chain rule is something that can be used a lot of different ways, a lot of different times in calculus, and it's going to be extremely, extremely useful. So let's look at an example here. Let's say that we've got a particular function here. H of x is equal to 3x plus 1 quantity squared. Well, that's simple enough. I could simply square that out, and that becomes 9x squared plus 6x plus 1. Simply foiling. Don't forget how to FOIL. All right, and then if we took the derivative, so we want h prime of x, so that would be 2 times 9, which is 18x, plus 6 plus 0. So basically this would be our answer right here, 18x plus 6. But let's look at this if we were to use something, basically the chain rule. So let's look at it a little bit differently. So let's start with a function f, which is basically we're going to square something, okay? So we take what's in the parentheses and square it. We have a function g, which takes what's in the parentheses, multiplies it by 3, and adds 1 to it. So therefore, if I've got f of g of x, in other words, in place of x, I'm going to plug in g of x, all right? So what's in the parentheses is going to be 3x plus 1, and I'm going to square it. So this right here is another way of looking at this right here, all right? Same function, but two different ways of looking at it. All right, now instead of multiplying this out, let's use the chain rule for finding the derivative. Chain rule says we take the exponent, just like the power rule. That goes out front here. This 3x plus 1 stays the same. We reduce the exponent by 1, so 2 minus 1 is 1. Then we take the derivative of what's inside the parentheses here. Well, the derivative of what's inside is 3. So what do we end up with? We end up with 3x plus 1. 2 times 3 is 6. 6 times 3 is 18. 6 times 1 is 1. And we end up with the same answer as we had before, but now we did not multiply it out. Now, granted, this was a fairly simple example, but it shows how we can use the chain rule. So if you're looking for a basic definition, our basic definition would look like this, all right? And again, remember back for our nomenclature for composite functions. So if I got f of g of x, all right, the derivative is going to be the derivative of x, okay? I'm sorry, the derivative of f, the derivative of the f function, f prime, okay? Then times the derivative of that internal function, g prime of x, okay? So let's look at a more complicated example, one that we couldn't multiply out, but we could use the chain rule for. All right, so let's look at this example here. I've got f of x is equal to 6x minus 5, 2x cubed minus 1 raised to the 4th power. Yeah, theoretically I could multiply this all out. I don't want to because of that right there. But what do I have here? If you notice, what do I have is product rule. And you might think of that as u, you might think of that as v. So I've got u times v, all right? So how do I figure out using product rule as well as the chain rule, because I'm going to need the chain rule for the v portion. All right, u prime is simply going to be the derivative of 6x minus 5, which is 6, all right? Times the v, which is 2x cubed minus 1 raised to the 4th power, plus v prime. All right, this is where we use the chain rule. Take the exponent out front here, 4. Keep what's in the parentheses, but drop the exponent to now 3, 4 minus 1 or 3. Now we go inside and we take the derivative of what's inside the parentheses. That's 3 times 2 x to the 1 less, or 6x squared, all right? And then we simply multiply it by u. So I'm not going to multiply this all out. I could if I wanted to, but this basically shows fairly easily how you can take a complicated problem, use the chain rule, and come up with the derivative. All right, let's look at some more examples here. I want to find f prime of 4 given the following. So I know what g of 4 is, I know what g prime of 4 is, I know what h of 4 is, and I know what h prime of 4 is. Okay, so let's look how we might solve these. So let's start with the first here. So we got f of x is equal to g of x quantity squared, and I'm going to use the chain rule. All right, so f prime of x is going to be 2, take the exponent, times g of x to the 1 less exponent. So it's going to be 2 times g of x times the derivative of g of x, so g prime of x. Okay, so that's just using chain rule right there. Now we're going to plug in, because we want to know f prime of 4. So every place I see an x, I'm going to plug in a 4. All right, so what's g of 4? G of 4 is up here. G of 4 is simply equal to 4. So there's your 4 right there. Your 2's out front. What's g prime of 4? G prime of 4 is equal to minus 2. There's your minus 2 right there. So I got 2 times 4 times minus 2. I come out with an answer of minus 16. All right, let's look at this other example. I've got f of x is equal to h of g of x, all right? Here's your typical chain rule, all right? So f prime of x is going to equal h prime of g of x times g prime of x. But we want to know the value where x equals 4, so I'm going to say f prime of 4 is equal to h prime of g of 4, parentheses, g prime of 4. Well, first of all, what is g of 4 right here? We always work inside out on parentheses. G of 4 is simply equal to 4, so that becomes 4 right there. What about g prime of 4, which is right here? G prime of 4 is equal to minus 2. Okay, but now I've got h prime of 4, which is right here. H prime of 4 is equal to 5. So there's where I get the 5 right there. I already have the minus 2. 5 times minus 2, our answer comes out to be minus 10. So as you can see, you can use chain rule in a lot of different applications where the functions get really, really complicated. And that's the beauty and advantage of the chain rule.